Good afternoon, students. For those of you who were in class yesterday, this video is basically a review of everything I went over. For those of you who are taking the test, this is my attempt to help you get caught up with where we are. I assume you guys are all up in Mr. Johnston's room, and I am downstairs with a couple of the seniors who are presenting their theses to Mr. Luddy. So, you should have up on your iPads the Google Slides presentation, and you should also have your textbook open. And I'm going to try to explain what's on those slides and direct you to some places in the textbook, and then hopefully you'll be equipped to begin solving the problems on pages 299 through 301. So, what we are working on with this, really our last unit in logic, is dealing with a different kind of argument. We've dealt with syllogisms, particularly the classical, traditional, categorical syllogism, what's also called the simple syllogism. This is the same sort of syllogism that Aristotle first analyzed, and logicians throughout the Middle Ages developed all these different ways of solving for validity. Whether they use the Barbara Celarant rhyme scheme or testing through Aristotle's 6 rules. But now we're moving on to a different kind of syllogism, and this is called a compound syllogism. This kind of syllogism is much more modern day, and it uses a different kind of structure. So because it uses a different kind of structure, we're going to take a different approach to solving it than we've taken before. I'm currently on slide 14 on this slideshow. There are 3 kinds of syllogisms that you need to be familiar with. The first is called a hypothetical syllogism. That's the same sort of syllogism that you've worked with in geometry before. That is an if-then statement. If I sleep well, then I will be well rested tomorrow morning. This is a very common kind of statement, but we'll do a lot more with that here in just a few moments. The second kind of compound syllogism is called a disjunctive syllogism. Rather than establishing a condition like the previous syllogism, this one establishes an exclusion. Either one thing is the case or something else is the case. Either I am currently sitting in my library or I am not. Those 2 things cannot both be true at the same time. This is a disjunctive syllogism. Now, the third kind of syllogism is called a conjunctive syllogism when it's put together with multiple propositions. When these are just these propositions, they're called conjunctive propositions, but that's the both and construction or the not both and construction. Now, we will deal with compound syllogisms 2 and 3 next week. For this week, we are working exclusively with the hypothetical syllogism. And this is now on to slide 15 on the slideshow, where here's what you will need to do. If you are dealing with an if-then type syllogism, the first thing you need to do is use symbolic logic to help reduce this to a more comprehensible form. So rather than putting a syllogism into the same logical form method that we've done before, we're now going to use a more modern method called symbolic logic. What this does is it takes each part of the syllogism and it gives it a letter. So the first part of a disjunctive syllogism is the phrase that begins with the word if, and then the second part of not a conjunctive syllogism, that's a hypothetical syllogism. The first part is going to be the part that begins with the word if. The second part is going to be the part that begins with the word then. So with these 2 parts of the sentence, we're going to call the first one the letter P, as in Peter, and the second one's going to be the letter Q, as in the word quiet. So, when we have a more complicated sentence or syllogism, we can simply extend this out to more letters, R, S, T, and so on, until every section of the syllogism has a letter. What this is going to let us do is very quickly show the different relationships between these clauses. So, once I have taken my line and I now have a syllogism, I now have it reduced to letter P and letter Q, I need to also demonstrate the relationship there. And that's where, if you look in your textbook, you'll see that the letters P and Q are joined by a leftward-facing horseshoe sign. That horseshoe sign is indicating the implication. So the way we would read that sentence is if P, then Q, where if everything that is represented by P is true, then Q will also be true. So the different parts of this syllogism have names. I want to make sure you're familiar with them so that you understand how we judge for validity in the next section. The if phrase in a hypothetical syllogism is going to be called the antecedent. The antecedent is it's from a Latin phrase that means coming before. So the antecedent comes before the rest of the sentence. So our first clause is going to be called the antecedent. That's the if clause. The then clause is going to be called the consequence because it is caused, or it is the consequence of the antecedent. So if I have a disjunctive or a hypothetical syllogism, if I sleep tonight, then I will be well rested tomorrow. The if I sleep well tonight part is the antecedent, and then I will be well rested tomorrow is the consequent. It is caused by the part that comes first. Now, in working with symbolic logic, there's a couple other symbols that are rather helpful. And those are both in your textbook, and I'm just going to describe them. There's one that's called a tilde, T-I-L-D-A is how you'd spell that. It is a symbol, it's a little squiggly line that will appear next to the P or the Q if we need to negate the P or the Q. So instead of writing out not P, we're just going to have a little squiggly line with P, and that stands for not P. So if I wanted to say, if P then Q, but P is not the case, therefore Q is not happening, what I would have is P, horseshoe, Q, and then tilde, P, and then my therefore symbol is going to be a triangle of dots. That's just the traditional way of, instead of writing out therefore, just kind of put this dot, dot, dot there, and that signifies the word therefore. On page 291, I'd encourage you to read through the 4 examples there. If this is confusing as I'm describing it without showing it to you, on page 291 you'll see how all this is kind of laid out, and you'll see how Craif takes these different syllogisms and he really breaks them down so that we can see really clearly how they're working together through these different symbols. Now let me finish this up by walking you through the 4 possibilities. This is on page 292 of your textbook, where there are really 4 possibilities for what is going on in a hypothetical syllogism. The first is a syllogism that affirms the antecedent, meaning that we have our same proposition, if P, then Q, where the second line of the syllogism is going to be simply the letter P, meaning P is happening, P is true, P does in fact exist, and therefore Q is going to be the case. Now, because we are affirming the antecedent, we're affirming that the antecedent is correct, and therefore it causes the consequence. Now, this is our first form that this can be in, and it is in fact a valid form. The second possibility that we might have is called denying the consequence, where denying the consequent is looking at that same relationship. If P is the case, then Q will be the case, because these two things are related such that P causes Q to exist. Well, the second form, denying the consequent, is going to look a little bit different. We're going to start the same way. If P, then Q. The second line is going to be a tilde and a letter Q, meaning Q is not the case. Therefore, P must not be happening, or therefore not P. This is called denying the consequent, and it works, it's valid because the two statements are necessarily connected. So if the consequent is not happening, then the thing that causes it must also not be happening, because these two things are so tightly connected to each other. The third form is called affirming the consequent. This is an invalid leap of judgment, because affirming the consequent looks at the consequent and assumes that because the consequent is happening, therefore the antecedent must be true. This is a flaw in thinking, because maybe something else caused the consequent to be the case. But this can be a hypothetical syllogism, but it's an invalid one. This one would look like if P, then Q, And this one would then say Q is the case, therefore P. Except that in this case, that would mean that that's a false way of looking at it, because it removes any possibility of something else causing the consequence to exist. Now, the last possibility then is denying the antecedent. This is another invalid leap of judgment. And you'll see there, this is all laid out for you in your textbook with all the symbols and the kind of the formulas there. Denying the antecedent is going to then look like our same if P, then Q, but then we're going to say not P, therefore not Q. And this is going to be this is going to also be an invalid syllogism. So with that, Mr. Johnston should have the exercises that I prepared for the students who were in class yesterday. Those are really a way to kind of get a better handle on this. Let me explain how those work, and then I'll explain what your actual assignment is that you'll be working on over the next few days in logic class. Yesterday, I had everybody in class begin working on a set of exercises from a philosophy professor at Dallas Baptist University. He put these exercises together, and he very helpfully grouped them all together under these 4 possibilities. So you don't have to guess which one each of these should come out with. They're all organized, and he also gives you the Latin name for each of these possible relationships. What I want you to do is to use those to begin kind of making sure you can figure out what is the antecedent, what is the consequent, and how are they related. It should not be hard. What I want you to do is literally look at each of the examples and then write the formula next to it of what that symbolic statement would come out as. And several students who were in class yesterday got started on this. I'm sure they can help you with piecing that together if necessary. Once you've really finished that part, you're not going to turn that into me for a grade. That's just practice to kind of get a hang of this whole symbolic logic idea. Once you've finished that, what I want you to do is turn to page 299, where you will see the beginning of 26 exercises. Each of these are hypothetical syllogisms. Some of them are epikairemas, some of them are enthymemes. But what I want you to do is begin working through one at a time how each of those can be reduced to symbolic logic. Each of those 26 exercises is going to reduce to a symbolic logic formula. If P, then Q, where P or Q is affirmed or denied, and there is something that is then concluded that's either going to be P or not P, or Q or not Q. Once you have finished that, then you'll need to judge that for validity based on which of the 4 possibilities you find it to be. As with all of these, you do have the answer key to the evens in the back of the book. You do not have the answer key for the odds, but please feel free to use the answer key to the evens to help sort this out. And if you run into some that are just too tricky that you want help with, please feel free to skip that and move on to another one. We'll come back together on Tuesday and try to solve as many of these together as we can. Your homework Tuesday night will be to come into class on Wednesday with a list of 26 that you have solved. So you've got all day Friday. You will not be in class on Monday because Miss Roberts has asked for you guys to be there for a chemistry lab. But then you'll have class on Tuesday. The quiz next Wednesday, which will be our last quiz in logic class, is going to be a quiz on hypothetical syllogisms and symbolic logic. So, use your time today well, and I'm confident Mr. Johnston will be quite capable to help you solving through these. But get to work, and I look forward to seeing you all next week.